Good evening, everybody. It is October 30, 2023, and this is the weekly Victoria Centre of the Royal Astronomical Society of Canada Astro Cafe, and I am pinch hitting as chair for this meeting, and might be fun. Oh, well, first of all, who has things to talk about? David Lee and Lauri. Oh, I gotta write things down or I'm gonna forget. And
you'll have to remind me what I'm gonna tell you about. I think I know what it is.
Yeah, I've got the list, David. That's fine.
Oh, okay.
And I think there's somebody named Randy wanted to present it too, didn't he?
I have a couple more talks from October 14th to give. Just to remind people who are not here, you don't get the jet puffs if you don't come on purpose, unless you buy them yourself. But
can I have some jet puffs?
There we go, Leslie.
They're Viva Puff. Viva Puff, even better.
But it's gross to buy a whole package just for yourself. But if you share them, it's not too bad. Let's start, because there's some people that I hadn't met before, to say hi if you want to. And so we have next to me Matt.
Yeah, Matt Neild or Matthew, not Max or Pat or anything like that. Yeah, second year in RASC, and been enjoying my time down on Cattle Point, meeting a few people on an ad hoc basis. Mr. Lee, yes, many conversations and troubleshooted some of my stuff, and Ken McGill down there a fair bit there too. So he's probably down there tonight, but yeah, so really enjoying it, and meaning to get out to a Monday for a long time. There's always been something going on or an excuse, but not tonight. So glad to meet everybody and glad to be here.
Right, and it sounds like the astrophotography SIG has been useful for you. That's great.
Well, and then an engineer as well, so it's probably par for the course. Yeah.
And then we have some visitors from Switzerland who are going to present next week, but I'll have them introduce themselves today.
Hi, I'm Ewan, and this is my wife Michaela. We, as we just heard, we live in Switzerland. We live in the Swiss Alps, and we're just here visiting actually for a couple of weeks because our daughter just moved to Victoria to work. She's a marine biologist, so she's found a lovely place to come and make her future career. So we're members of the Astronomy Society in Vevey, which is just sort of between Montreux and Lausanne, just northern side of the lake Lac Léman, which you probably know as the Geneva Lake, but the locals don't call it Geneva Lake. So we're keen amateurs. We're very much at the amateur end of amateur astronomy, but we have lots of very good friends at the society who are pretty sophisticated and have a lot of very good kit. And we're also very interested in subjects of light pollution. We have a working group on light pollution within the society. We've had several round tables in different parts of Switzerland, not only in the.
There can't be any light pollution in Switzerland.
You'd be surprised. You'll see some data next week. I think you're probably a lot better off than we are, actually.
Really?
Yeah, we've been doing quite a lot of work with that, and we also write children's books as the kind of post-corporate life jobs. And the first one is on the subject of light pollution, so maybe we'll share a bit of that with people who are interested next week as well. Okay, thank you.
And thank you so much. And Cameron and Lisa have a new member here too.
Yeah, this is Max, probably the youngest member. That's Victoria, maybe at least. And we're really excited to be able to show him our telescopes once, he's old enough to stay awake that long. And although, he is up in the night at very dark times through the night. So
So
know?
Lisa, the big question is, does Mac have a telescope?
Oh, he doesn't have his own telescope yet, but I'm sure we can lend him one.
Does he like the moon?
Oh, I'm sure he does. You know, I don't think I've shown it to him specifically though. But I know my niece sure loved the moon once she learned about it, and so she would always point at it. So we'll teach him about that too.
And how's your dome?
Good, the shutter's off right now because I started fiberglass, like the shutter was getting kind of funky and rotten in a couple spots. So took it off in the summer, started fiberglassing. Unfortunately, my mom passed away suddenly. That was right after he came along. So yeah, so things just kind of up with the nice white tarp and yeah, so a bit of a reset. So hope to get it back. It's just too damp out the fiberglass now. So just we'll retackle it in spring.
Okay,
Yeah.
great. So Jim, I was just taking over while you were not here, but I've been just going through new members or visitors. I haven't looked in the virtual world if there are new people there.
Yes, well, welcome everybody who's come to the meeting in person and in Zoom. It's wonderful. I'm going to have to check on it. I had the meeting scheduled starting at 7:30, but I think there may be a bit of a mix-up between my schedule and the Zoom schedule. So my apologies. But we do have a few topics for this evening, and I believe Randy, you have a talk coming up about a conjunction, and then also David has some information about the Maker Sig, and we'll see who has anything else from that.
So Carlos, are you a new member?
Hi everyone. Yes, I joined can you hear me?
Yes.
Perfect.
Yep. Okay. I joined the RASC like about 2 months ago, and I've been following you for maybe 8 months or so. I always listen to the Astronomy Cafe Tuesday mornings when I go to work. So I really enjoyed the meetings, and yeah, this last September I kind of decided to officially join the RASC, and hopefully I can get to know everybody a little bit more. I have 2 little kids, so I'm not able to drive all the way down to Victoria. I live in Sydney, so I try to get the best I can. Whenever I can, I go to the observatory there and take the kids with me. But yeah, I had my hands full right now, so whenever I can, I'll try to meet you in person for the next event that you have there. And yeah, I'm happy to be here.
Welcome.
Do we have any other new members? Anyone who has just joined recently or due to the Zoom meeting, perhaps?
Well, we have a missing in action person who showed up. Francois is here, I see. Hi, Francois. We see dark.
Ah,
He's hiding. He's muted.
oh, there we go. I see him now. Hello, Francois.
Francois, before we started recording, said that he's just waiting for a meridian flip so that he can get back to his astrophotography.
Oh.
A good way to while the time.
It's an excellent thing to be waiting for, so that's all good. So, Randy, did you want to go ahead with your
Right.
talk?
Okay. There. And then we go here. So yes, at the eclipse party on October the 14th, Lauri invited me to do color commentary, and I made 5 short talks. And so I've shown 3 of them to you, and now I'm going to get a couple which are a bit more into the weeds. But I think that you might be interested to see some of the deeper ideas of what happens with eclipses. And one of the big ones is that the 14th was not a total eclipse, which is when the moon covers the whole sun. The moon was smaller than the sun, and it was because it was a micromoon as opposed to a supermoon. So let's go into that a bit. So there is this cosmic coincidence that the sun is much, much larger than the moon, of course, but it's much, much further away. And for no good reason, it just happens that the moon and the sun are both about half a degree in size. The sun does change. It has as part of its 11-year cycle, it changes a little bit, but it's not very much. Whereas the moon does come closer and moves further away from the Earth. So its angular size changes. But I love this pair of photos here. So the International Space Station is what? It's about, I think it's 100 kilometers above the surface of the Earth. Chris, is that correct? Anyway, it's got a certain size, which is going to be the same in both of these pictures. But you see, compared to the circle or the curvature of the sun and the moon, you see it's about the same size. Okay, why is that? Well, because the moon does not travel in a perfect circle around the Earth. It goes in what Kepler showed to be an ellipse. Before Kepler came along, there was a complicated system of wheels within wheels, and you had, at the same time, they knew that the sun, the moon did not go around the Earth in a perfect circle. That was not Kepler's observation, but it was his recognition that you could mathematically describe the orbit as an elliptical path with the principal body at one focus. And I put a little star there because it's not the bigger body at the focus of the ellipse, it's actually the center of mass, but the Earth is so much bigger than the moon. It's very close. It's I think it's something like 15 kilometers from the center of the Earth. Okay. So the thing is that there is a time each month, each lunation, when the moon is at perigee. Para means close. G is like geometry or geography is the Earth. So at perigee, the moon is 33.5 arc minutes in size. And when it's at apogee, so as far as it can get from the Earth, then it's under 30 minutes. It's at 29 and 2/3, 29:40. No, it's 29.4. Anyway, it's a very small difference. You cannot measure it without instruments. It's something that people try to do. And in fact, the Greek orbits with its epicycles and things made a completely crazy prediction that when the moon is closer, it would be twice as big as when it was far away. And that was clearly contradicted by the naked eye observation that they were pretty similar. But they're, to first order, they're both around 30 minutes of arc. But in fact, the moon can get quite a bit bigger. But you can't actually see, it's not a big difference. And when people say, oh, did you see the super moon last night? It's mostly the moon effect. It's when you see the moon against the horizon, then you put it in context with things that you know the distance away from, and then it says, whoa, that looks really big. But if it's way up in the sky, you don't think it's that far up. You think it's only as high up as the clouds, which are much closer to us than the edge of the horizon. And so you feel the moon is not that far away, and so it doesn't feel as big. That's the moon effect. That's not what we have when we're talking about supermoons and micromoons. So after several failed attempts at trying to measure the size of the moon, in 2020, I received, let's see, can I do this? As a birthday present, well, I chose it and then my family paid for it. Because they didn't know what to do. But this is this beautiful 1941 sextant that was deployed on the Canadian Navy. And it eventually ended up in this fellow's private collection. And then when he died 20 years later, the kids sold it. And it's fun to, you know, sit out on Dallas Road and try to figure out where we are. And my wife says, you don't have GPS on your phone? And I do, but I got my location with this at about, I think about 4 kilometers, 5 kilometers off what it was supposed to be. That's not bad. But what I really use it for is I measure the size of the moon every time that I see it. Okay, and it's been beautiful these last few days. And I write in my little book. I always have my book with me, and I write the size. And I can pass this around as show and tell. It's pretty robust, so don't have to feel worried. So this was the first 1,000 days of measurement, and the colors, the blues are full moons, the reds are you know, thin crescents, and what you can see is that the moon does indeed get closer and further away. It's pretty noisy. My measurements are only good to about 30 seconds, I figure. But I fit a sine wave, and I got exactly, I mean, to within, what, 90 minutes, I got what's called the anomalistic month. And we can talk, well, I think my next talk, I'm going to talk about the different durations of the month. So just know that the anomalistic month is how long it takes from perigee to perigee, from closest approach to the Earth to closest approach to the Earth. And it's about a day shorter than, no, 2 days shorter than the 29.5 days that you go from new moon to new moon. So when the moon is closer to us at perigee, then the angular size is over 30 minutes, over half a degree, and it puts a big shadow, well, not a big shadow, but it puts a shadow on the Earth. Whereas when the moon is further away, the umbra, the zone where the one limb of the sun and the light from the other limb of the sun are both obscured on Earth at the same time, then because it's not on the surface of the Earth, it's somewhere up in the atmosphere. It means if you're down in this section called the antumbra, then you actually see a ring. You see a bit of light on all the way around the moon. And that's when you get this ring of fire. So here it is again, looking sideways. When the sun is fully obscured by the moon, then there's this path along the surface of the earth of totality. So on April 8th, when this happens, when the moon is in front of the sun the next time, it's going to make a path from Mexico through Texas. That's where the serious people who really want to see the eclipse are going. But then it's going to come just south of Toronto. It'll go through Niagara Falls, up the Lake Ontario. We'll go through Kingston, Montreal. That's where I'll be. Fredericton goes into Newfoundland. So this is going to be wonderful, and we'll get lots of news about this as we come along. I think it's 162 days. My Facebook tells me every day how many days to the eclipse. But on the 14th, that path of totality was way up in the sky somewhere, and down on Earth, you had a path of annularity where you only saw a ring. Okay, so that is the difference between when the moon is far away, it's a micromoon, and when the moon is close and it's a supermoon. And what it looks like on ground, well, they both start off pretty well the same. Or if you're in Victoria and you get an 80% eclipse, you see pretty well the same thing, whether it's a total eclipse or a annular. But along the path of annularity, at maximum, you get the ring. But if you wait until April, then there's this magical moment when the moon obscures all of the bright part, the photosphere, and you can take off your glasses and see the very, very faint part of the sun that we never really get to see normally. So just to point out how bizarre it is that the moon is about the size of the sun on Earth, that's what an eclipse on Mars looks like. So Phobos is tiny, but it's really, really very close to Mars, and the sun is quite a bit further away. I don't actually know the angular size of the sun on Mars. I would guess it's probably half the size of what we see here. But so yeah, in 2013, it was actually photographed. I think that's fantastic that they were able to catch that picture.
Who took the picture?
NASA. It's the Curiosity rover.
It's curious.
So this is not an eclipse, it's a transit, but it's when Venus went in front of the sun for the last time in something like 300 years. And I hope that many people remember that wonderful day. I certainly enjoyed watching it. I think Sherry took a great picture. And wonderful pictures from John McDonald of transits of Io and Ganymede in front of Jupiter. But so that is certainly what you would call an annular eclipse. The moons would be smaller than the sun on Jupiter. So these are the three sorts of eclipses. What you normally get when you're not trying hard to get to the center of an eclipse. And I think I've seen maybe a dozen eclipses, but only partial. I've never been to see totality. And of course, I'm going to Montreal in April, so it's going to be cloudy that day. But I'm going to try. And then the annular, like we just had. And I think that's the end of that talk. Oh, these are a few extra pictures. This is not stuff I showed on the 14th, but I should show you this. This is important. How do you measure the size of the moon? And you set the movable mirror, the adjustable mirror, to around 1/2 degree, so way over here, and you jiggle it back and forth. And if you see that the one reflection overlaps the other reflection, and I totally faked these, okay? This is not, these are not real photographs. This was me taking one picture of the moon and copying one over the other. But anyway, imagine that you're seeing these two reflections in the eyepiece. If it's over on like the picture on the left here, then you've got it too small. And if they're no, this way you're saying it's too small. This way you're saying the moon is too big, but you get it just so that the points meet and it's just right. Okay, and that's pretty much what I do each time that I see the moon. I pull out my sextant and I do exactly that observation. You've seen this. I don't have to show you this anymore. Okay. So this is a talk that I gave last time. And that's a talk I gave last time. But we're going to talk about the Saros cycle now. So in a similar way that there's this crazy cosmic coincidence that the moon is about the same size as the sun, there's another absolutely crazy set of coincidences that leads to this 18-year, 11-day, and 8-hour Saros cycle. And the thing that delights me is that the Babylonians knew about it. Like this is, it's pretty tricky. And yet with the observations that were available 3,000 years ago, people figured it out to quite excellent accuracy. You know what a solar eclipse is? There are 4 types of lunar months. Okay, and we're going to go through these 4. So the sidereal month is how long it takes for the moon to go 360 degrees, one full rotation around the Earth. And sidereal means based on the stars. So it doesn't matter that the Earth is moving in things, but if you take a look how long it takes for the moon to say pass the Pleiades to when it comes to the Pleiades again, that would be 1 sidereal day. And it's a bit under 27 and a half days. Okay. But during that 27 and a half days, Earth has gone about 1/12 of the way around the sun. And it's going to take the moon 2 more days to go from where it was after 360 degrees to where it's got to be in the same place with respect to the sun. And I love the word synodic, because a synod or a synod is like what the Pope just called in Rome, right? He called all the cardinals to Rome and they had a gathering. So a synodic month is when the moon and the sun gather, when they are in syzygy, which is another great word. Syzygy, SYZYGY, which means the planets or the sun that are in alignment is a syzygy. So that is the normal month, the one that we usually talk about, that 29 and a half days. The reason that we in lunar calendars, you do a 29-day month and then a 30-day month going back and forth, it's because you want to keep it aligned with the phases of the moon. Now, the moon does not travel around the Earth in the same plane that the Earth travels around the sun. And you can never get an eclipse when the moon is above the ecliptic, the plane that we're going around the sun, or when it's below. The shadow of the moon will pass either to the south or to the north of the Earth. But twice a year, you're on what's called the line of nodes, when the moon is in syzygy with the sun, so is in line with the sun, and the shadow is going to hit the Earth. It's not, the shadow isn't above, the shadow isn't below, it actually hits the Earth. And that happens twice a year. And so it's very important to know how long it takes for the moon to get from one node, there's the antinode, and then back to the node. And that month is called come on, what is it called? Oh heavens, I forgot the name of it. It is not the anomalistic. Oh, the draconic month. It's called the draconic month because the dragon eats the sun. Okay, there's the whole thing of why does the sun get smaller? Why does the moon get smaller during a lunar eclipse? And it's because of the dragon. And so it's called the draconic month because you can only get eclipses when you're within half a degree of the node. Good, I remembered. Yeah, the draconic month is the time it takes for the moon to make successive passages through its ascending node. You can see how it goes up and then it comes down. Where that's important for eclipses is, remember this, on October 14th, we were on the descending node. The eclipse started in Oregon, went down through Texas, and then met up in Brazil. It went south. Whereas the ascending node is what's going to happen in April. The eclipse is going to be moving to the northeast, not to the southeast. It always starts in the west, but during the ascending node, the path is going to go from Mexico through Texas and then up to Newfoundland, going on. So the moon is going rising north or above the ecliptic, whereas in the descending, it's going to the south. Okay, there's the dragon who eats the sun, right? That's why it's called the draconic month. Okay, the anomalistic month. This is the one that I was measuring with my sextant. Okay, it's from perigee to perigee. How long does it take for the moon to get close to the Earth? And the reason that's important is because you get some eclipses are total, some are annular, and this is the distance or the size of the moon because of its distance from the Earth that is changing. Okay, now we come to the crazy coincidence. Forget the sidereal month, but it's interesting in a way that 241 sidereal months is about 65, 85 days, but it's not close enough. But take a look at the next three. These are funny integers. Like this is just a coincidence. This has nothing to do with resonances and things. But 233 new moons is 6,585 and a third days. 242 draconic months. So you can only get eclipses when it's a new moon. So that's got to be an integer number of synodic months. When you're at the node, so you have to have an integer number of draconic months. And look at that, 242 gives the same number, 6,585 and a third. And then not too far away is the anomalistic month, which determines if you have a total or an annular eclipse. And 239 of those gives you 6,585 days and about a third. Okay, that's where the 18 years, 11 days, and 8 hours comes from. And so what that means is that every 18 years, there's going to be an eclipse that if it's in the descending node, it's going to move from the south to the north every 18 years. And that's called the Saros cycle. Each of these moons will have the same Saros number. So just to take a look what that looks like, here are the October 14th in the middle and the previous and the following solar eclipses. So you see the two in the ascending node and this one going down, and there's nothing similar about them. But if we take the three Saros 134 eclipses and look at them, you see how similar they are? But they're 1/3 of the Earth around from each other. If you come back another 18 years, so that would be in 2059, then it's going to be over North America again. But they're very, very similar because of that cosmic coincidence of those 3 lunar months being an integer number apart. Just amazing. Why am I showing you this? This is each eclipse of Saros 136 over something like 3,000 years. And so you see each time the Earth is going 1/3 of the way around and whoops, off the top. So starting again, we're in the 15th century, 16th, 17th, 18th, 19th. Oh no, we're up to the 20th century, 21, 22, 23, 24, 25, 26, 27, and it starts over. These are all one cycle, and you see how this particular type of eclipse is evolving over time. Fantastic. Now, I told you the Babylonians knew about it, but also, have you heard of the Antikythera mechanism, which was found by pearl fishers off a Greek island called Antikythera? I don't know, I think it was in the 19th century. They pulled it up, said, what is this? But now they're doing CAT scans and they're doing all different things to try to figure out what's going on inside. And it turns out it is clockwork. This is from over 2,000 years ago, but beautiful clockwork, and the number of teeth are all there to work out when the next eclipse is going to be using the Saros cycle. So this is a recreation and showing how you can calculate the synodic, the anomalistic, and the draconic months, all from just clockwork, way before they thought they even knew how to make clocks. Absolutely awesome. Okay, I'm not going to go through this. It's a wonderful diagram, but what I want you to see is this is the year, January, February, March, all the way around, and the time, the year, or the decade actually, is each ring, and you see one Saros cycle is in each of these things, each of these lines. And so like the ones with the black, those are the total eclipses. This Saros cycle is all total eclipse. The one that we just had, the annular eclipse, was I think this cycle here. And if you blew it up, you could see the dates. Oh yeah, there we are. So that was the one that we just had in October. And that's where I'm going to stop. Bit more in the weeds than the last couple, but you gotta have some of that sometimes.
Gets the brain working.
Thank you very much, Randy. That's it's mind bending trying to hold those cycles in your mind, but the fact that those 3 particular months, the draconic, the sidereal and the
Anomalistic.
not along anomalistic. Yes, thank you. I'm trying not to look down at my notes here. So, just the fact that they add up to within a few hundredths of a day is quite remarkable. And you can see how pre-calculus and pre-instrumentation, how these eclipses could be predicted, which I find still thinking back on how the court astronomer of whatever particular empire it would have been, being able to predict that an eclipse would occur on a specific day.
They had a secret trick though. 500 years of observations.
Yes, yes,
It helps.
yes.
You don't have to be that accurate if you've got time.
True, and it's, with that much observation, you could tell that you were getting to the third sorrow cycle, so you could expect that something was about to happen. Still, it's very.
I don't promise this is my last eclipse talk. We've got just 5 months to go before the big one across Canada. I'm sure Lauri will be talking about her work also. But then the next one is going to be, I think, in Canada is something like 2044. I know I worked out I'll be 83. So, take your chance now. That's it for North America, unless you go way up into the Arctic, or you're going to be traveling a long way. So plan accordingly.
Well, for long-term plans, I have my eye on 2061 for the next comeback of Halley's Comet. So 2040 is not that far away.
I think the next transit of Mercury happens before that.
And actually, the measuring the moon, you've inspired me. I have it's just a plastic training sextant, but I think tonight or when I have the chance, I'll definitely be trying out the moon measurement as you were describing it, to see how accurate I can get.
Yeah, we're just after perigee, and so it's starting to come down again.
Well, thank you very much. And did anybody else have any questions or comments for Randy? Okay, well, very good. Then we can move on here. David, did you want to say something?
Yeah, I just wanted to respond to a question from Marjie from the beginners group. I noticed a lot of people were observing the closeness of Jupiter to the moon. I'm avoiding the word conjunction right now. So many sources didn't really cite it as being a conjunction. And Marjie asked me why. So here's why. So I wasn't sure myself. Often when things get close to each other, like either planets or planets to the moon as such, I've often just called it a conjunction. But apparently, by definition, they have to share the same right ascension. So, for instance, Saturday night, I think Reg and I were both up at the VCO and we we're watching the moon rise, actually, this is another story, which I hope Reg will tell. Anyways, the moon was rising, and of course we saw Jupiter sort of underneath of it. And I think even we questioned whether it was truly a conjunction. We didn't really know. But anyways, it has to share the same right ascension. So just as a reminder, this is the RA-det coordinate system here. The long lines here that radiate from Polaris are lines of right ascension. So they have to follow along here in order to qualify. I don't know. I'll still call things that are close together conjunctions, but technically this is the true thing. Now, interestingly enough, even though this particular event where Jupiter got close to the moon, the night when I saw it on Saturday night, it actually didn't share the same right ascension, but of course that changes over time. So I worked it out. I went into Stellarium and just kind of rotated the times around, and sure enough, at 1:10 the next day, or not, just an hour and 10 minutes after midnight, the two share the same right ascension. So it's, at that point, I would say you technically could call it a conjunction. But anyways, this seemed to have prompted a lot of conversation on email. But Marjie, did you discovered a list of conjunctions coming up? Is Marjie there? I hope
Yes,
Oh,
I did.
yeah. Did you want to speak to that?
Sure. I had looked on the internet for a list of conjunctions because the Explore the Universe program offers an opportunity to record a conjunction. So in order to do that, I had to know when they were. It wasn't an easy find, not in the Observer's Handbook or on the internet. So I found some, and the one I found that I thought I would take a look at is December the 22nd. But after this discussion about conjunctions, again, this last few days, I went back to the internet and took a look to see if I could find anything else. And I did. So there's a website called Derek Scope, DEREKSCOPE, derekscope.co.uk. And on that site, I'm assuming there is a Derek, he or whomever, excuse me, lists all the conjunctions between 2022 and 2025. They are all in Greenwich Mean Time, of course. So there's one between the Moon and Venus, November 9th, Moon and Mercury, November 14th, Moon and Saturn, November 20th, Moon and Jupiter, November 25th, Moon and Venus, December 9th, Moon and Mercury, December 14th, Moon and Saturn, December 17th, and Moon and Jupiter, December 22nd. And all of them except one, the November 9th, is at 2:30 a.m. our time. But all the rest of them are anywhere from 7 a.m. until 10 p.m.
Oh, perfectly suitable
Now,
for Cattle Point people.
yeah, so now becomes the question for me as to whether or not on a clear day with sunshine and a good sky, whether or not
When
I
when you have something going on the my phone in the car, it goes, I can't do it.
Yeah.
It's weird.
Kathy, you have Kathy, yeah, thank you. So yeah, so the question for me would then becomes, and I will have to try find this out by taking a look as to whether or not I can actually see that conjunction on a clear day with sunshine. I don't know, because I've never looked at a conjunction in the daytime. So
it has to be a very bright object in order to do that. So
yeah,
what you're going to have to do is do all your time conversions and
done
check the times, right?
yeah.
So
Yeah.
they would still work. Now you're questioning whether you can see them because of
It being daytime.
still daytime. Okay. Well,
Being
I would
daytime, because these are all except for one. I've done the conversions. They are all during the day.
there aren't any at evening for us local time.
Only one, and that's the one coming up on November the 9th. It's at
Mhm.
2:30 a.m.
Okay. Yeah, that's a little bit late, eh? Except for crazy people. And Joe, Joe, you got your hand up.
Yeah. When you saw the conjunction or looked at it on Stellarium at the correct, everybody's got the equal right
Yeah.
angle ascension. Were they even close together? Because they were very close together.
Oh, they were like at cross midnight. They were still quite close. In fact, Reg and I were at the VCO when it had risen above the trees, and we could see it hanging there, right?
It was the same night. It wasn't a different night.
Well, okay. We went to the VCO on Saturday night,
Yeah.
but it didn't reach by definition conjunction until 1:10 the next morning. So just a couple hours away, right?
Close enough. Thanks.
Close
Yeah.
enough, yeah. I don't know. When I see them close together, I call it a conjunction.
So
but I'm just talking about the technical aspect of it.
But I assume they're all on the ecliptic, right? More or less.
More or less, yes.
So
more or less.
They assume that the right ascension is the same. So
yes,
if they're at the extremes on the ecliptic, they might not actually
exactly
be that close together.
Yeah.
Or they could be on the exact same eclipse.
Yes.
And be very close together.
Yeah, you're right, because okay, if they are conjunctions of planets and the moon, obviously they all travel along the ecliptic more or less, right? So the planets don't land on the ecliptic exactly, like they're kind of off a little bit as you go to the ecliptic itself. But this is just by definition. I go by look anyways, like how close they are. The common conjunctions are the ones between planets themselves. So we've had some quite famous ones recently, right? Like Venus and was it Venus and Jupiter? I think it was. Recently, a couple of years ago, we had one that was really close together.
Saturn and Jupiter.
Yes.
Yeah, I can't remember which ones they are.
It was Saturn and Jupiter.
Saturn and Jupiter? Okay.
Yeah, we were at Dallas Road together that night.
Oh, okay. Thank you for reminding me. Bill, you have a question?
Yeah, so Marjie, were any of those Venus?
Oh yeah, that's right.
Moon? Because around noon, I can't remember how many years. Yeah, so a Venus one in the daytime for sure.
Yeah, you could do that.
If it's all you have to do is look for the moon. So because they're all easy because the moon is there.
Yeah, if it's a lunar one.
Yeah, and so with binoculars, Venus will show up. Jupiter might even still, with like a small telescope, Jupiter will also, but Venus would easily show up with binoculars.
Okay, that's December 9th at almost 10 a.m.
Yeah, so I have some photos of like when the moon occulted Venus, and I have a progression of shots of Venus coming out using just my 6-inch Dob and a point and shoot camera that showed them. Yeah. They're on Zenfolio somewhere.
So my question then is for the ETU. I was thinking that I couldn't use the moon and Jupiter that occurred close together, and the conjunction that I was in bed for on recently. I assumed that I couldn't use that because it wasn't actually, they were close, but they were officially not in conjunction. So
but they were at 1:10, as I said. I checked the RA at 1:10 on the next calendar day, and it was the same RA.
But I would assume that for the ATU that I would have to see it at 1:10.
I'll ask that question of the group.
Might be close enough.
I have a feeling that we're not going to be really tight on the true meaning of right ascension and conjunction.
That's what I need to know.
It's like when they're close together.
Okay.
That's how I do it too. Like I don't go check.
Vote for. That's what I would vote for in a discussion with the observing committee. I don't think people are going to like.
They were certain.
2 hours later was the exact time.
They were less than 2 degrees apart.
Hey! Tonight, the moon is in conjunction with the Pleiades.
Oh yeah, it is. Yeah.
Would that count?
What's a
Suppose
conjunction?
it's not really an object. Well,
multiple
it's
stars.
it's usually two objects though.
Yeah.
Well, okay,
The Pleiades is an object.
is it?
It's a Messier object.
Yeah.
Okay,
It has an
all right.
it has an NGC number.
Okay, I buy that.
You should be on Trump's legal team.
I guess that's gonna rule out photographing the Pleiades tonight.
So in the ETU handbook, it says conjunction, when two or more celestial objects appear close together in the sky, it is called a conjunction.
Right.
Close enough for me.
Yeah, certainly for me too. I'm just wondering why people do or do not include them in lists, and I looked up the definition, and that could be a reason why.
The moon is 1.6 degrees south of the star cluster at 10:30 a.m.
That'll look really pretty in a binocular.
Yeah.
But it'll be close now when you go out tonight.
True. They'll already be close.
So in other words, I have a conjunction.
Oh yeah, I think you saw one on Saturday.
But if you want to look up where they are, because it's very important to them, is look up astrology websites.
Oh yes, that's where conjunctions are a big deal. You're right. I keep forgetting about, and they have their own definition of conjunction as well. Anyways, if we probably should leave this topic. I've got a couple other things.
Before we leave this topic, I'm responsible for this, and I'm feeling a little bit ashamed because I sent out a notice to the Hill Obs, the active observers list, that there would be a conjunction tonight. Even I was writing that, I said, oh, somebody's going to get me. So I feel like I've just attended my court martial.
No, I think you've been exonerated, Reg.
Well, I was a cavalier remark, and I think I'm in danger of being
I had the old one.
Society. So there you go.
Well, that was a pretty conjunction we saw, Reg, right above the trees.
It was excellent. I like the more forgiving definition that Marjie found there. So it's good.
Excellent.
I figure any two bright objects in a pair of binoculars counts.
Yeah, and they were within a binocular view too. Yeah. All the more reason to call it a conjunction. Anyways, we can keep debating if we want, but
you get conjunctivitis from conjunctions?
Conjunctivitis, or yeah, maybe.
And it's not but an and.
You opened up a can of worms, Reg. Yeah, we probably should leave the topic.
Just as a note, if you want a conjunction of two definite objects on Thursday the 9th, actually it would be probably the night of Wednesday the 8th, 1:30 in the morning on Thursday the 9th. The Moon and Venus conjunction will be happening. So that's 1:30 in the morning on the 9th of November.
Yeah, well, it's possible. You never know. Okay, I've got a couple other topics. I'm just going to move on to them now, I think. So last week, I announced that we were having a maker sig last week, and that turned out to be not true. But we're going to have it this week, and I'm just going to go over some of the topics just in case people are interested. I'll just go into share here. So as I mentioned last week about the makers group, we're kind of a bit of a tinkering kind of group. So basically we have a couple of topics, a number of topics kind of lined up, and they've been prompted by things I've been doing. and also by some of the things that Jim's been doing. So the first one is about managing equipment for observing and imaging. I don't know about the rest of you, but I find I have like a lot of equipment. So I've sort of developed my own kind of method of storing things and building checklists that are for purpose-built things. So I'll be willing to share those with you. The other thing is the ASI Air is an extremely popular kind of an imaging tool. It's a replacement for using a laptop computer when we do imaging. And there's a lot of us that use ASI Air in the group or in the Victoria Center, but I've been exploring an alternative platform. Now, ASI Air is kind of uniquely for ZWO equipment. It's its own ecosystem, so it kind of relies on the fact that all your equipment is ZWO. So there is an alternative sort of solution to this. Excuse me, it's called Astronomy, and it runs basically on the same platform the ASI Air does. So they run on these little computers called Raspberry Pis. And so this alternative is actually something called Astronomy, which is kind of an open source tooling, which is very, very similar. In fact, it uses similar tools. For instance, in ASI Air, it uses PhD 2 for guiding. Well, so does Astronomy. So there's a number of sort of equivalents for it, and it's manufacturer agnostic. So it means that you can mix and match manufacturers' equipment. So that's what I've been exploring. I'll tell you a little bit about my progress with that. The other thing I'd like to do at the Makers SIG is also talk, because we are a group of tinkerers, I'm asking if we could maybe get some additional volunteers for the telescope clinic that's coming up at a future FDAO Star Party, which is, I think, November 18th, I believe. 18th, right. And
Yeah.
and Lauri might talk a little bit more about that and when it's time for her to talk. The other two things are really based on my observations of our host, Jim, this summer. I noticed he was using ham radios for different events, and I thought, is this astronomical? And I thought, oh, I guess it is. So I asked Jim, and he told me a little bit about what he was doing, and all astronomy related. But I guess ham radio has a lot of kind of activities which are kind of related to astronomy, or can be related to astronomy. So I'm hoping that Jim will talk to us about that. So if you're interested in the SIG, I know not a lot of people come out to this particular SIG unless it's for a particular purpose. But this is the address here. This is my email address. So if you go here, just send me an email. I will send you the link for that. So we can do that. Just while we're on the topic for the telescope clinic, we're going to advertise this and open it to the public. Right now, I have Bill Weir, myself, and Brock Johnson, who are going to be your resident mechanics. Well, I'm not really a mechanic, but I'm calling myself a mechanic. Anyways, the clinic will take place on the 18th, and we're going to talk a little bit about fixing kind of common problems. Also maybe instructing people about the different parts of a telescope, because they may not be aware of what those are, and a little bit about kind of general maintenance for those things. So yeah, so that's what we hope to do. I don't know, Lauri, did you want to kind of add anything to the clinic story?
Yeah, hi. So this is going to be a regular star party that that we have, except that instead of having a speaker, we're going to have the clinic instead. And so we're hoping that people will come out. And I mean, I would think that there will be some, obviously, like some presentations of what's happening, but we also want people to bring in, bring in a telescope that doesn't seem to be working, or that they got in a box and that they need to have help as to what part goes where, that kind of thing. but it will be open to the public. It will have the same ticketing. We're now at Yep Desk instead of Eventbrite, because unfortunately Eventbrite decided to start charging for free events, like for charity organizations like ourselves, and we just couldn't afford to keep going with it, which is too bad, but that's just kind of what happens. So we've switched our ticketing, and it seems to be working okay. If you're interested in coming, we'd love to have you come up. We'd love to have you help with this. David would, and David and Brock and Bill will be happy to have people helping. But we also will need, just like our regular group that will be doing, we'll still have our children's program. We still will have our dome tours, our planetarium tours, all that kind of thing will go on. Let's hope that it's a nice night, and that we can take some of the telescopes that maybe we can put together a little bit. We can put them outside so people can have a little bit of a look. So we're open to lots of ideas and suggestions. If anybody's got anything, like, please, bring us along. We're just kind of going to, we've never done this before. So this is going to be something that's a little bit different for us.
Lauri, I just thought of another thing that this might be good for. Somebody who's just beginning, that doesn't have a lot of experience with telescopes. This might be a great opportunity for them to look at different types of scopes and ask questions about them, and possibly even handle them. Like, we have quite a large number of scopes. In fact, I'm actually hoping there are people from this group that will help us in next season operating some of the telescopes that we have. You don't have to have your own. We'll show you the ropes, and you can help us do telescopic things with the public.
Yeah.
Great.
So that's great. That's great. Thank you.
Well, Lauri, is there any more information about the dome?
It is the part of it has been fixed, and we're waiting for one new wheel to be remachined and put in. I believe that there is some very small movement of the dome, but not huge at all. So it's still not being fully used for research at this point, which is a shame. But it's coming. It's close, because some of the manufacturing is being done here and on the mainland, I believe. So it's not like we have to go to Germany or Switzerland. Hi, Switzerland people. In order to be able to find in order to be able to find a spot. So we're hoping that will work. Yeah.
Great. Thanks, Lauri.
Yeah.
So I think that's about all I have tonight. Except, Reg, are you able to sort of report on things that have happened up at the VCO?
Just briefly, the VCO is 15 years old, and there's a Gary oak tree north of the VCO, and that has extended its reach over the last 15 years. So I took a photo and I sent it to Derek Mann at NRC, and I said, there's a bit of an issue with this. And he immediately sent a request to Marilyn Bell, and they got an arborist up there, and they've trimmed the tree way back. And I don't have pictures with me tonight because I didn't bring my computer, but it's a significant improvement. It's through the kindness of our good friends at the NRC.
Great. Yeah. It was quite a surprise to see that, actually.
Well, one thing it did is that by removing the leaves and branches, it allowed great shafts of moonlight to stream in. In fact, it was so intense, I received a moon burn from this.
Very good. Yeah, so there's lots of stuff going on at the VCO, and we're hoping more of the mix are going to join us so they can be trained, so they can start hosting sessions. I would say a number of us have been working on workflows for imaging. We've used many of the scopes for visual use of late. So I think that's been pretty successful, right, Reg?
We're pretty excited about the developments there, but the one thing that we should emphasize is when we gather up there, we have a lot of fun. It's great for fellowship, astronomical fellowship, kicking around ideas up with a great vista. It's a wonderful location. So when we send out a note to the active observers list, please give it some consideration, and we'd like you to join us up there.
Oh, Lauri's got her hand up. Lauri.
Are we going to get another picnic table up there?
That's in the budget.
Okay.
That's the hope. Yeah, so that's all I've got for tonight.
Well, thank you very much, David.
You're welcome.
Actually, you just prompted me. I didn't have anything I was going to add, but I'm going to take a moment here, talking about amateur radio and connection to astronomy.
Oh, okay.
For I believe it's the 65th anniversary of the launch of the first satellite, Sputnik. The Russian contingent on board the International Space Station has been sending some slow scan image pictures over amateur radio that can be picked up here on Earth. And I'll just do a quick share here.
So is image transfer a very effective?
Yes.
Is that an effective vehicle for?
Oh yes, yes. Let me show you. So these actually. There we go. Is that coming up now?
Yeah.
Okay. This series of images I received on my here at home on my computer and over my VHF radio on the 2 meter band as transmitted from the ISS as it made various passes earlier today. So there were 3 passes. One of them was not too high. The other one was very high inclination in the sky, up to about 80 degrees, I believe, almost directly overhead. So a couple of these came through really well. And one of them was quite low, and you'll see the
Is this in a special format, or is it just?
Yes.
Oh, it is special format.
This is a system called Slow Scan TV, SSTV.
Okay.
And one of the really interesting things about this, well, actually, I'll just show you the quick run through here. This is medium quality reception, and that's not a really good quality reception. So this was one of the lower passes. It was fairly low. Again, fairly good reception, and not too good, and then pretty good. So anyway, there are a series of 12 of these images that the ISS is going to be, or is transmitting, and I'm hoping, that I'm going to be able to get them all. So if I do, I'll manage to get a special QSO card response from the Russian Space Institute for all of this. But,
so Jim, when it transmits, is there any kind of error correction, or does it just dump a bunch of stuff and you hope you get it?
No, unfortunately, it's there's no back and forth. It's strictly a one-way transmission.
Okay, so it just dumps it, and you hope you get the whole thing.
That's right. Now, one of the interesting points about this is that I was just looking back today at some of the pictures from. Hang on a second, I'll stop sharing here. I was looking at some of the pictures from Voyager, one of the first Voyager passes across Jupiter, when they took the first really detailed pictures that showed us the swirls in the clouds and the details in the cloud tops. And I remembered, this ties in with this, that at the time in the late 1970s, when these were actually transmitted, there was no effective way of transmitting them. The internet and data transmission really hadn't occurred or hadn't been invented yet. So the pictures, these wonderfully detailed pictures that came out and absolutely astounded everybody, were taken from the reception center at JPL to the JPL Amateur Radio Club station and were sent out to the world via slow scan television. So all of
interesting.
Reached the news the next day or so by the amateur radio operators at at JPL. So these were this was interesting, tying in with astronomy, this and space. These pictures that I received here were very dependent on tracking the ISS and getting a good pass, a good high pass, so I could receive the well, have long enough. It takes about 2 minutes to transmit one of those pictures, and having it high enough that I could receive it fairly well. So, so that was
I guess there's a lot of moving parts in this business. It's just we may not be aware of them because so much of it is a black box to us, right?
So it was fun tracking these down, and it's interesting that our subjects sort of came together here. So
good, excellent.
So Jim.
Yes.
Your radio it's upset by coronal mass ejections, right? And not just normal prominences?
Yes, that's right.
Okay, because I had that discussion this Sunday with a guy when I was doing outreach at the market with my solar scope, and there were some fabulous prominences, and this guy from the local ham people out in Machosin, he was saying that, yeah, those things really upset our radio. I said, I don't think so. I think it's when the sun sends out essentially a sun fart, like when they do their ejections, that those
a
are
CME,
what really
right?
upset.
Yes.
Yeah, coronal mass ejection.
Yes. Again, as David says, there are a lot of moving parts to this. There's the solar activity cycle when it reaches its peak, which it's coming up to in the next couple of months now. That provides you with a very highly ionized upper atmosphere that allows you to do long distance transmission. So there's that, and then when you have a coronal mass ejection, it can disrupt the ionization in the upper atmosphere, and then can also affect the magnetic field, which has a totally different effect on the transmissions. And then you also have to look at the frequencies. The frequencies that I was actually receiving these pictures on, it was a very high frequency. There's a history in radio. They started off with the high frequency, which is down in the megahertz range, and then they around the 1930s they found that they could get above megahertz range into 10 or into the 100 megahertz range, and they called that very high frequency, and then ultra high frequency, and so they kind of gave up after they went to extremely high frequency, ultra high frequency, extremely high frequency, and now they just give numbers to the bands. But in those higher frequency ranges, the ionosphere doesn't affect the radio signals at all. So that's why the very high frequencies are used for satellites up in the gigahertz range, especially. So there, that was a very confusing introduction to a very complex subject.
For more, join the Makers Group.
Yes. Radio propagation is known as a black art, and that's pretty much why. Now, does anybody else have anything else they wanted to bring up? We usually have some pictures. Reg, I believe you usually have some pictures from some of the other groups, or I'm connecting that with somebody else. But does anybody have anything else they'd like to bring up?
The Pearson kids had a wonderful Wednesday evening last Wednesday out at the Walmart parking lot out in the West Shore. We set up in one of the handicap spots because we got kicked out the last time we went there and set up on the doorstep. So we thought we'd just stay in the parking lot. And we showed a lot of people because it was great. The moon, Jupiter, and Saturn were up. And so we just kind of harassed people as they're going by. And it was a lot of fun.
So
the kids were able to go in and get food too.
Bill, what are
pantries?
Bill, what are your objects going to be for Halloween night? Have you thought about it?
I've tried going. Yeah, I've done it in the past, but the bonfire in Machosin is so huge. The air stability is just the worst. So, yeah, it's not worth it. It's just fun to go and watch the fireworks and watch the kids run around and get a free hot dog.
I thought I would try. I mean, the moon's not out, so I thought I'd try Jupiter and Saturn.
Yeah. Nobody comes to my place. I'm a long driveway. And it's a big party, so nobody's really interested in stopping and looking through a telescope.
Mm.
It's mayhem. It's little kids running around in costumes. It's more fun that way.
It's actually given me an idea. We're about a half block away from Tim Hortons here at occasionally set up a telescope outside. So tomorrow night, if it's clear, that might be an idea to go out with the telescope and a basket of candy and see who I can lure into looking.
I used to do that regularly in Edmonton for Halloween. I'd set the telescope up on the driveway and every kid that came by got to look at the moon.
Yeah, that's what I've been doing every year, except I don't think there's a moon tomorrow night.
Was that a trick instead of a treat?
Yeah. So, Chris, do you have any news from the web?
As a matter of fact, I do. Just give me a moment here. And so what it is a new image came in today, or at least in terms of into my email. So you see that?
Oh yeah.
Mhm.
Oh, that's familiar.
So this is the Crab Nebula, and the image at the left is one from Hubble, which is I think it came down a few years ago, but the one at the right is just been newly processed from Webb.
Oh wow.
And you can see there's some differences, especially if you look around the fringes there. But also deep inside now. The Webb image apparently kind of points a bit more effectively, although I can't replicate it myself, but they do have a little animation if you go to the Webb website that leads you to the pulsar that's at the center of the Crab Nebula, and so this is going to put some scientists to work trying to figure out a bit more about the background and structure of the Crab Nebula and the history, of course. So that's what I've got for you today.
You know, Chris, it almost looks like a veil has been lifted because there's so much detail in there by comparison.
That's
like
right.
Like fine detail.
That's right. That's right. So so this is just one press release. I mean, I usually get 2 or 3 a week, but this one kind of got my attention. So that's what I've got for you today.
Oh, very nice.
It's interesting to see the difference in the change in the frequencies that they're using in the wavelengths, as well as the newer instrument. So very interesting to see the differences. Lauri, I believe you were trying to. You wanted. Yeah. You try. I did see you wave earlier. So
okay.
Anyway, please go ahead.
I wanted to let people know that, as I said last week, that the calendars have come in, and I am slowly getting them to people. They will be $15 a piece, and I gave some to Jill, today. Jill, did you get them? I hope so. On your front door, and she will be passing some of these out, and I will be definitely there on the 11th of November, on the Wednesday of the 11th, at UVic, in order to, is it the 11th? No.
No, it's the 8th.
Sorry, the 8th. Yeah, sorry. The 8th, I'll be there and I will hand out to whoever is there, who's on my list. I'll be able to give the calendars to then. We have got extras. So if anybody is interested in signing up, please just let me know. And today I actually did get in the order for the almanacs and the handbooks for the moon and Explore the Universe. And they're going to send those out. Renee Drummond is going to send those out as soon as she can get them out. So they should be here within about well, I'm hoping by the time we have the time at the at UVic that they'll be here. So I think that's all I wanted to say about that. Please just let me know if you'd like a calendar.
Lauri, is the payment preferably in cash?
We take anything.
Oh, okay.
Except for, unfortunately, we don't take an e-transfer. That we're not set up for that, but we'll take cash or we'll take checks.
Okay.
While we're on the topic of
Darren,
that,
thank you. Yeah.
while we're on the topic of that meeting at UVic on the Wednesday, the November 8th, our speaker that night is Dr. Brenda Matthews. She works at NRC Hertzberg, and she's her field of study is radio astronomy, but she is using the ALMA array, which allows you to get very detailed information around young stars. And she will be showing some of the results where they can actually see planets forming in the debris disks surrounding stars. So it'll be a very interesting talk that's right up to date. So please keep that in mind. The talk starts at 7:30 in room A140 at the Bob Wright Center at UVic. And afterwards, we open up the astronomy lounge and library for coffee, cookies, and conversation. It's going to be a great night. I hope to see you there.
This is A104?
A104.
Not A140.
A104. Did I say A140? I led you astray. It's A104. Thank you.
Okay. Okay.
Jim, you're muted.
Ah, I wasn't muted before. I clicked mute when I wanted to speak. So that's I was saying, Lauri, you'll have to be careful about that cash and check is not the same as we take anything. So you might want to clarify that and make sure you don't have people showing up with goats.
Or chickens.
Or chickens, yes, yes. No. Does anybody have anything else? Anyone else would like to bring anything up? Do we have any questions for our previous speakers? Well, that seems to be everything then. So we're getting on towards 8:30. Well, it's past 8:30 now, so we've been about an hour and a half, which is a good time for a meeting. And I'd like to thank everybody for coming out tonight. And welcome to our guests from Switzerland, and also to our new young member there. And we'll hopefully be seeing a lot more people, or the same people, and even more people next time around for our evening. So at that, I'll call it a close and bid everybody a very good night. So thank you for coming.
Thank you.
Good night.